Assalamu alaikum and hello everyone. Welcome to Mathematics with Shahab Yaqub. So now it's time for the exam, and there are some topics of S1 that we have studied. So it's time to review them for the mid-year exam. That is the syllabus content, and we have done everything in probability. Let me just highlight it a bit for you. Now, keep in mind that this session will take around at least 90 minutes, 1.5 hours. It could also go up till 2 hours. So just sit back, relax, and enjoy the show. Topic 5 is probability and statistics. That is paper 5. 5.3, candidates should be able to evaluate probability in simple cases. Just ignore whatever is written over there. By calculation or using permutation or combination, we have done all this. Use addition, multiplication of probabilities as appropriate in simple cases. This I seriously doubt. It's not always that simple. Understand the meaning of exclusive, that is mutually exclusive, independent events, and whether events are independent by comparing the values of intersection and their individual probabilities multiplying together. Calculate and use conditional probabilities in simple cases. We have used this thing, but they are saying explicit use is not required. You can do without it also. And as far as this is concerned, this particular formula, I have not taught you as of now. It will be taught up later. Without it, we have already done the things. So that is the syllabus. Let's look at the first question. It says a box contains 3 red ball and 5 blue ball. One ball is taken at random from the box and not replaced. And then it further says a yellow ball is then put into the box. A second ball is now taken at random from the box. Now, the very first thing, initially, there are two colors, that is red and blue. So let me label them. So this is red, this is blue. And then a third ball now enters the show, that is the yellow ball. So we are talking about red, we are talking about blue, we are talking about yellow, then red and blue and yellow. That is the color that you have to label. The second thing, that is initially 3 plus 4, that is 8. When we write down the probabilities, this is what is present in the box initially. Out of 8, you will be choosing the numbers. So this is 3 red, this is 5 blue. Now, when one ball is taken out, the denominator drops to 7, so 8 becomes 7. But then one yellow ball is added, so the total becomes 8 again. So therefore, the denominator is 8 all along. And then if I focus on the color red, so red to red, the 3 will be reduced to 2. That is the first thing. Similarly, if I talk about blue, blue to blue, and this is 5 will become 4. That is right over here. Now, first of all, this number of blue is the same as the previous one, that is 5. And this yellow is 1. So yellow remains constant. Again, this yellow is 1. And this red over here, the numerator, that's the same as the previous one because blue was taken out. So therefore, this is 3. That is the first and foremost thing. They're not giving us, yes, they are giving us. They are giving us some marks for filling it out. Complete the tree diagram, show all the outcomes and the probability for each branch. That is exactly what I have taught you in class. So now we were talking about this. Let me recap it. 3 red, 5 blue. 3 out of 8, 5 out of 8, red and blue. One ball is taken out, the denominator drops to 0. One yellow ball is added, the denominator becomes 8 again. Red, 3 becomes 2. Blue, 5 becomes 4. This 3 is this one. This 5 is this one. One yellow, that is the thing. Outcome, let's write the outcomes. So that is the color combination. That is red, red. This is red, blue. This is red, yellow. This is blue, red. This is blue, blue. This is blue, yellow. Let me also color code it. There is no hurry. We will study with style and understand it thoroughly. So let me label all the R's over here. Let me label all the blues over here. Let me label the yellow. That is this one. That is yellow. Okay. So these are six combination. The denominator is 64. 8 into 8 is 64. Do not reduce the fractions. 3 into 2 is 6. 3 into 5 is 15. 3 into 1 is 3. Similarly, 5 into 3, that is 15. 5 into 4, that is 20. 5 into 1, that is 5 over 64. So now this is all done. Find the probability the two balls taken are of the same color. That means they could be red, red, or they could be blue, blue. So red, red is 6 over 64. Blue, blue is 20 over 64. This is 6 over 64 plus 20 over 64. That comes out to be 26 over 64. As such, there is no need of reduction. Find the probability that the first ball taken is red, given that the second ball taken is blue. Now, second ball taken is blue. Let me highlight it. Second ball is blue. That is this one. Second ball is blue. That is this one. So these are the two options, red, blue, and blue, blue. So given that goes down in the denominator, that is red, red, plus not red, blue, and blue, blue. Hold for a second. So red, blue, and blue, blue. So this is red, blue, and this is blue, blue. This is part 3. Find the probability first ball taken as red. So out of which first ball taken as red, red, blue goes up. So now, first of all, red, blue is 15 and blue, blue is 20. This is 15 over 64. This is 20 over 64. This is 15 over 64. This is 15 over 35. That comes out to be 3 over 7. So now let's double check the result. 26 over 64, 3 over 7. 26 over 64, that is the reduced form, and 3 over 7. So now the first question is done and dusted. I won't be wasting time in asking for acknowledgement on the WhatsApp group. You all are seeing it. If there is any issue, you would be pointing it out in a separate message. The next one. Now, this is also one nice classy question, 2018 paper. It says vehicles approaching a certain road junction from town A can either turn left. Let me start with red color. Can either turn left or turn right or go straight on. Over the time, it has been noted that the vehicles approaching this particular junction from town A, 55% turn left. So that probability is 55%, 15% turn right, 30% go straight on. So left is 55, right is 15, and straight is 30. The direction a vehicle takes at a junction is independent of the direction any other vehicle takes at the junction. So they are not related to one another. Part 1, find the probability of the next 3 vehicles approaching the junction from town A. One goes straight, one, and the other 2 either both turn left or both turn right. That means for 4 marks, they're asking us either, let me just reduce the brightness, either it would be straight and both turn left. So SLL or SRR. Now, let me write down the probabilities over here. So there are 3 probabilities. That is the red one, then there is the blue one, then there is the green one. The red one is 0.55, the blue one is 0.15, and 0.30 is this thing. And they are left, and this is right, and this is straight. So just multiply it out. SLL. So that is this green one. This is green. Right is blue and blue. And this is red and red. So therefore, this is 0.30 into LL. That is 0.55 into 0.55. Or is add S is 0.30 into R, which is 0.15 into 0.15. Now, what is the missing piece of the puzzle? The missing piece of the puzzle is arrangement. SLL can be arranged in three ways. SRR can be arranged in three ways. That is why they are giving 4 marks. So technically, that is how they will be grading it. 1 mark for this, 1 mark for this, 1 mark for this, 1 mark for this. That is total of 4 marks. The next one. Now it says 3 vehicles. They are talking about 3 vehicles approach the junction from town A. Given that all 3 drivers choose the same direction at the junction, find the probability they all go straight on. Given they all choose same direction. What does that mean? That means all 3 could be going left, or all 3 could be going right, or all 3 could be going left. So this is SSS, first one LLL, and then RRR, and then SSS. This is the denominator of this thing. All follow the same direction. So let me write it over here in the denominator. And let me draw a line. And then LLL, that is 0.5 cube. So this is 0.55 cube. RRR, that is 0.15 cube. And this is 0.30 cube, that is the denominator. Find the probability they all go straight on. That means the product of the 3 green ones that goes at the top. SSS, that is 0.30 cube. Again, I won't be wasting time in doing calculation. I'll just show you the working. So now look at this working. Look at this working. Let's double check. That is 0.3, 0.55, 0.55. This is 0.3, 0.15, 0.15. 3C1 is 3, 3C1 is 3. So they have taken this, multiplied with 3. They have taken this, multiplied with 3, and added it. And now 0.15 cube, 0.55 cube, 0.30 cube, 0.30 cube goes at the top. Okay, now let's look at this thing. A fair 8-sided die has faces marked such and such. When the score when the die is thrown is the number that the face lands on. So that is the score. The die is thrown twice. That means there are how many options? That is 8 into 8. There are 64 options. 1, 2, 3, 4, 5, 6, 7, 8. So 8 into 8 is 64 possibilities. That is the first thing that you need to think. Event R. One of the score is exactly 3 greater than the other. So now let me highlight this. How can you have one of the score exactly 3 greater than the other? That means if I choose the number, so event R, the difference is exactly 3. It could be 1, 4. It could be 2, 5. It could be 3, 7, 3, 6, my bad. It could be 4, 7. It could be 5 and 8. So these are the different options that you are getting. And of course, the order can change. So 1, 4 can become 4, 1. This is 5, 2. This is 6, 3. This is 7, 4. This is 8, 5. Because there are 2, you're throwing it twice. So maybe you're getting 1 first and then 4, or 4 first and then 1. The difference is exactly 3. So event R, there are 10 options. So probability of R, that is 10 over 64. All good, all clear? The next one, event S. What is event S? So this is S and this one is R. The product of the score is more than 19. So now first think 1 into 2, 1 into 3, 1 into 4, 1 into anything that is not going towards 19. 2 into 1, 2 into 3, 2 into 2, 2 into 4, 2 into 5, 2 into 6, 2 into 7, 2 into 8. That is also not there. So now I think it would start with 3. So therefore, 3, 5 is 15, 3, 6 is 18. So therefore, I have 3, 7 and I have 3, 8. And of course, I can change the order. Similarly, with 4, 4 fours are 16, 4, 5. And let me write it vertically below. This is 4, 5 and 4, 6, 4, 7, 4, 8. What about 5? 5, 3 is 15, 5, 4, 5, 5, 5, 6, 5, 7, 5, 8. What about 6? 6, 2, 6, 3, 6, 4, 6, 5, 6, 6, 6, 7, and 6, 8. Then we have 7. 7, 2, 7, 3. 7, 3, 7, 4, 7, 5, 7, 6, 7, 7, and 7, 8. What about 8? 8, 3, 8, 4, 8, 5, 8, 6, 8, 7, and 8, 8. Now, there are some of them which can be multiplied by 2. So, which ones can be multiplied by 2? 1, 2, the different ones, 3, 4, 5, 6, 7, 8, 9, 10, and then 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, and this is actually I've written all of them. You don't have to multiply by 2. 20, 21, 22, 23, 24, 25, and then 26, and then 27, and then 28. So since I've already written, you don't have to multiply by 2. So therefore, probability of S, that is 28 over 64. Now, these two things are done. Find the probability of R, find the probability of S, determine whether events S and R are independent, justify your answer. So first look for probability R intersection S. Is there anything common? 5 8s are 40. This is common. 8 and 5 is 40. 7, 4, 28. 4, 7, 28. 6, 3, 18. No, 18 is not there. So there are 4 of them that is common. So probability of R intersection S is 4 over 28. Now let me add a page over here. What do we have? We have 10 over 64, 28 over 64. Probability R intersection S, is it equal to question mark? Probability of R into probability of S. So this is 10 over 64. No, this one is 4 over 64. The intersection is 4 over 64. This is 10 over 64. This is 28 over 64. Multiply it out. I don't think so. So therefore, if it's not equal, therefore it's not independent. Let me check the red one. That was 10 over 64. 10 over 64, that's right over here. Let me check the blue one. That is 28 over 64. That's right over here. Let me check the third one. That is the purple one. That is 4 over 28. That is the common one. 4 over 64, not 28. I don't know why I wrote 28. That is 64. So this is 64. That is the purple one. And it's 64 over here. Now it says, yes, it's not equal, therefore independent. They are not independent. Now, first of all, someone was asking this question. I have listed everything down. So maybe if I listed 3, 7 and did not list 7, 3, then I would multiply by 2. But I've already done the job. I have listed every single possibility for the peace of mind. So now that was a nice question that we did. And let's do one question. Now let me pause this thing so that I can also check some WhatsApp. And then why don't you take 5 minutes, 6 minutes, try this out. Let me pause the recording. So now people, let's look at this question. It says box A contains 6 red and 4 blue balls. 6 red and 4 blue balls. Box B contains 9 blue and X red balls. A ball is chosen at random from box A and placed in box B. So now this is like that paperclip question, but it's in terms of X. A ball is then chosen at random from box B. So first of all, we will write, actually the probability is written, that is 6 over 10, 4 over 10, the two initial ones are written. Now the denominator is 9 and how many are chosen? This is x plus 9. So this is x plus 9 plus 1. This is x plus 9 plus 1, basically x plus 10. This is x plus 9 plus 1 because initially it was x plus 9 and then you transferred 1 from box A to box B. Now, how many reds were there initially? X. How many blue were there initially? 9. And then X and then 9. Now, focus on this red becoming red. So you should add something over here. Blue and blue, you should add something over here. So you should add 1 over here. You should add 1 over here. No harm in double checking. X plus 1 plus 9, that is x plus 10. The denominator is the same. So this thing should add up to 1. This thing should add up to 1. This thing should add up to 1. 9 plus 1, 10 plus x, that's the same as the denominator. Show that the probability both balls chosen are blue is this much. So now we have red, red, we have red, blue, we have blue, red, and we have blue, blue. Now they are asking both are blue. So basically they're asking this one, that is blue, blue. So this is 4 from here. This is 9 plus 10 from here. This is x plus 10 from here. Let me just double check. Yes, 9 is blue. So this is 4 into, both are blue. So 4 into 10 divided by x plus 10. Okay, so that is, show that the probability both balls chosen are blue is 4 over x plus 10. Now let me just check one thing. That is both are blue. That is 4 over x plus 10. This is 4 into 10 over x plus 10. Maybe they're asking for the second blue. So is there any other blue? No. So this is the individual probabilities, 4 over 10 into 10 over this. I think I forgot that 10. So there is also this 10 that I forgot to write. So that 10 is cancelling out. Okay. So now this 10 is cancelling with this 10 like this. Okay, all good. Now it is given that the probability both balls chosen are blue is 1 over 6. So basically this thing equal to this. So 4 over x plus 10 is equals to 1 over 6. 24 is equals to x plus 10. Therefore, x comes out to be 40. So part B is done. For this, x is 40. Find the probability correct to 3 if they're not asking in the exact form. Ball chosen from box A is red, given the ball chosen from box B is red. So now let me write it. This is RR. This is RB. This is BR. And then BB is already there. Given ball chosen from box B is red. So this is box A, this is box B. So therefore it could be red, red, or it could be blue, red. red, red, and blue, red. So that is the denominator. So let me first write it. That is red, red, and blue, red. Now, red, red is 6 into x plus 1 over x plus 10. 6 into 6 over 10, x plus 1, x plus 10. And the other one is blue red, that is 4 over 10 into x over 10. That is 4 over 10 into x over 10. All good? So now we have to insert, and ball chosen from box A is red. So therefore red, red goes up. That is 6 over 10 x plus 1 over x plus 10. Now, wherever there is x, just substitute the value, which is what? Which is 14, and then you will get the answer. All good, all clear? So now let's stop probability. Let's move to probability distribution, the second thing. So that one phase is all done and dusted. Now we are moving to discrete random variable, DRV, also known as probability distribution, also known as the chapter with expectation and variance. So that is what is written in the syllabus. Draw up a probability distribution table relating to a given situation involving a discrete random variable, calculate expectation and variance. So that is in this particular thing. In the next one, it will be this one, use formula for probabilities for binomial geometric. It's not yet done. So that will be this particular one. So this one is for binomial probability distribution. Yes, this is also part of DRV, binomial probability distribution, that is DRV extended. So let's first focus on this. And then, yes, this much we have done. Use formulae for expectation and variance of the binomial distribution, and for the expectation, that thing is not yet done. So whatever I'm highlighting, that is what we are focusing on. That is how they have written the formula. We have written the formula in a very nice way. So let's move on. Let's read this question first. It says the random variable x takes each of the values with probability of 1/4. Now, that is a nice way of saying that 1, 2, 3, and 4, they have equal probabilities. And therefore, this is like a fair dice kind of thing, because the probability is 1/4. So you don't even have to use this value. Two independent values of x are chosen at random. If the two values of x are the same, the random variable y takes that value. Otherwise, the value of y is the larger value of x minus the smaller value of x. So that is the instruction that we have. So now what I'll do is that I'll draw a sample space diagram. And of course, we know that everything has to be done in a particular way. So let me write 1, 2, 3, and 4. 1, 2, 3, and 4. Now, if the values are the same, x, y takes that value. So now, first of all, 1, 1 will become 1, 2, 2 will become 2, 3, 3 will become 3, and 4, 4 will become 4. That is the first thing. And then it's larger minus smaller if the values are different. So that would be like the positive difference. 1 and 2 is 1, 1 and 3 is 2, 1 and 4 is 3, 2, 1 is 1, 2, 3 is 1, 2, 4 is 2, 3, 1 is 2, 3, 2 is 1, 3, 4 is 1, 4, 1 is 3, 4, 2 is 2, 4, 3 is 1. All good. So now let's focus on how many ones are there. 1, 2, 3, 4, 5, 6, and 7. So if I draw up a table, and that's where the table comes in. So that is x, that is probability. So 1 is occurring how many times? 1, 2, 3, 4, 5, 6, 7. So 1 is occurring 7 times out of 16. What about the number 2? So that's 1. Let's start from here. 1, and then 2, and then 3, and then 4, and then 5. So 2 is occurring 5 over 16 times. What about the number 3? 3 is 1, and then 2, and then 3. So 3 is occurring 3 times, 3 over 16, and 4 is occurring only once, 1 over 16. Let's double check. 7 plus 5, 12, 12 plus 3, 15, 15 plus 1, 16, 16 over 16. Now, there was no use for this in this particular question if it was unfair. Maybe 1 and 2 had a probability different from 3 and 4. Then we would use the sample space and the probabilities. But that is not yet taught. So don't worry about for the exam, midterm exam. Draw up the probability distribution table. Find the probability y is 2 given that y is even. So now, first of all, second part. Given this is not x, by the way, this is y. Given that y is even. Now that could be 2, that could be 4. So that is 5 over 16 plus 1 over 16. This is the condition. That condition goes down in the denominator. Find the probability y is 2. So y is 2 is this probability, that is this one. Okay, so basically this is 5 over 16 divided by 5 plus 1 over 16. So therefore the difference, the division is 5 over 6. That is the answer. That is the table 7531. That is the answer, 5 over 6. Let's look at this question. The table is already there. The random variable x can only take this value. The probability distribution is given. Find the values of P and Q. The first thing first is this thing, that the sum of all the probabilities 1, 2, 3, 4, and 5 should add up to 1. So there is 2p, there is 2q, there is 0.1 equals to 1.0, 2 common, p plus q is 0.9, therefore p plus q is 0.45. That is equation number 1. The second equation this time is different. Probability x is greater than or equal to 0. Probability x is greater than or equal to 0 can be this and this and this probability. So this is probability x is greater than or equal to 0. That is 0.1 plus q, that is 2q. Is 3 times probability x is lesser than 0. So probability x is lesser than 0 is this and this. So that is this. So lesser than 0 is 2p. So this is 3 times 2p. So this is 0.1 plus 2q, that is 6p. So therefore 6p minus 2q is 0.1. That is equation number 2. Let's look at the equation. The first one is p plus q is 0.45. P plus q is 0.45. That is this one. 0.1 plus 2q is 3 times p. 0.1 plus 2q is 3 times 2 times p. That is the second one. We solve it simultaneously. These will be the values. I'm not wasting time on solving it simultaneously. Next one, spinner example. Just read this question first thoroughly. Someone has asked a question regarding the previous one. First read it. Let me just go back and check. I think someone asked about this orange table. Which is the orange table? This one, that is a sample space diagram. It is according to this rule. That is, if the two values are the same, the random variable y takes that value. So 1, 1 becomes 1, 2, 2 becomes 2, and so on. Otherwise, the value of y is the larger value of x. These are values of x. Larger value of x minus the smaller value of x. So that is the positive difference. And then we form this table. I hope this is clear. Now, looking at this question now, it says a fair three-sided spinner has sides numbered 1, 2, 3. A fair five-sided spinner has sides numbered such and such. So there is 1 and 2 and 3, and then there is 1, 1, 2, 2, 3. Altogether, there are 15 possibilities. Both spinners are spun once. For each spinner, the number on the side on which it lands is noted. The random variable x is the larger of the two numbers if they are different. Larger of the two numbers if they are different, and their common value if they are the same. So another question, uh, let me write it down. So first of all, the blue one, that is 1, 1, 2, 2, and 3. That is the blue spinner, and then the red spinner, that is 1, 2, 3. And let me draw some lines over here. Let me draw some line over here. There are 15 possibilities. So larger of the two numbers if they are different. There is no positive difference, and common value if they are the same. So first of all, 1, 1 is 1. 2, and then 1, 1 is again 1. And then 2, 2 is 2. 2, 2 is 2. And then 3, 3 is 3. These are the common values. Let me go horizontally because it's easier to see that. Larger of the two numbers. 1 and 2 will be 2. 1 and 3 will be 3. 1 and 2 will be 2. 1 and 3 will be 3. 2 and 1 will be 2. 2 and 3 will be 3. This is the same. And 3, 1 will be 3. 3, 2 will be 3. All good? Show that probability, again, the hint thing that I asked you, told you in class. Draw up the probability distribution table. This will be found automatically. So this 3 mark and 2 marks, they are interrelated. So now let me form the table that is over here based upon the sample space diagram that is over here. This is X, this is probability. The scores are 1, 2, and 3. So this is 1, this is 2, this is 3. 1 is occurring twice. 1 is occurring twice, 2 over 50. 2 is occurring how many times? So this is 1, 2, 3, 4, 5, 6, 6 times. 2 is occurring 6 times. That means 3 should occur the rest of the time. So 2 and 6 is 8. That should be 7 over 15. Double check. 1, 2, 3, 4, 5, 6, 7. All good? 7 over 15. So that is this thing. 2, 6, 7. That is 2, 6, 7. All good. Find the probability x is equals to 3. That is 7 over 15. That was found this thing. So this is part 2. The whole thing is part 3. And then it's basic stuff, expectation and variance. Let's move on. Colored item example. Now read this question once again, and then I'll solve this. Now it says a box contains 3 red and 5 white balls. So let me use the same color combination. 3 red in red color, but white in blue color. One ball is chosen at random from the box. It's not returned. A second ball is now chosen at random from the box. Find the probability both balls chosen are red. Show that the probability ball chosen are a different color. Given that the second ball chosen is red, find the probability first ball chosen as red. So now We are choosing two walls. We can do it with combination. We can do it with what you call probability thing. So let me just form a table. There is this thing that is 3 red and 5 white. So red and white. This is 3 red and 5 white. And let me write down in the probability format. So this is red, red, and then red, white, and then white, red, and then white, white. All good. Denominator 3 and 5 is 8. So the denominator is 8, denominator is 7. That is 8, that is 7, that is 8, that is 7, that is 8, that is 7. Red, red. How many reds are there? 3. So this is 3, this is 2. This is 3, white is 5, and then a 5, and then a 3. And then a white and a white, that is 5 and 4. So this is 6 over 56. This is 15 over 56. This is 15 over 56. This is 20 over 56. Let's double check. 15 and 15, that is 30. 30 plus 20, 50 plus 6, 56. 56 over 56 is 1. Find the probability both balls chosen are red. So part 1, that is this thing. This is answer of part 1. Find the probability that the balls chosen are of different colors. So different colors is this thing. So this is answer of part 2. That is 15 plus 15 over 56, which is 30 over 56, which is 15 over 28. That is the answer. Given that the second ball chosen is red, find the probability first ball is red. Second one is red. So that is this thing. This is second is red. This is second is red. So this is 6 over 56. This is 15 over 56. So part 3, that is this thing. This is red, red plus white, red, 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 and white, red. That is 6 plus 15. 6 plus 15 over 56. They are interested in red, red at the top. Red, red as 6 over 56. That is 6 over 21. Or this can also be written as 3 twos are 3 sevens are. So this is 2 over 7. This is 15 over 28. This one is the first one, 3 over 28. That is all good. 6 over 56 is 3 over 28. All good. Just have a good look. The random variable x denotes the number of red balls chosen. That is simple, straightforward. Let me just... No. It would disturb the whole thing. Hold for a second. Let me add a page. So now we are talking about x. We are talking about probability. So x could be 0, x could be 1, x could be 2. 0 is this thing, white, white. That is 20 over 56. 1 is these two. That is 30 over 56. And this has to be 6 over 56. Let's double check 20, 36. That is 20, 36. This is all in the reduced form. This is 20 when you double it. This is 30. This is 6. All good. Expectation and variance, no big deal. Probability distribution coin example. This is not yet taught. So there are some things in DRV. Yes, we have understood the concepts in and out, but this is not yet taught. Binomial probability distribution. Let's talk about this. DRV. And over here, let me highlight it again. What have they talked about binomial? Use formula for probabilities for binomial distribution. Recognize practical situations where these distributions are suitable model. and then it says use formula for the expectation and variance of the binomial distribution. For right now, this is what we are doing. So we know the rule that is X follows a binomial distribution, N comma P, number of trials, probability of success, probability XSR, that is NCR, success raised to power of R, Q raised to power of N minus R. Expectation of X is NP, variance of X is NPQ. And then there are some questions related to logs. They write this formula in this weird manner, okay? And this is for binomial and geometric. Geometric is not there. This is geometric. This ignore it, including the notation for binomial. So we're just focusing on binomial. Read the question first. Let me also check the WhatsApp if there is anything. Alhamdulillah, there is none. Now it says eggs are sold in boxes of 20. Cracked eggs occur independently, and the mean number of cracked eggs in a box is 1.4. So now over here, let me underline boxes of 20. Cracked eggs occur independently. Mean number is 1.4. Now, one thing about binomial is that there are certain conditions for binomial probability model to be effective. That is the first one. Number of trials are independent of one another. Now, what they have written about cracked eggs, that is the probability of success. It's occurring independently. The second thing, that is the probabilities are fixed. The probabilities are constant. And last but not the least, that is the number of trials are fixed. You will understand the difference when we'll be talking about geometric distribution in January. Now, once you have understood this, the very first thing that you need to know is that the formula for expectation, we just wrote it. X follows, let me just change the marker. X follows a binomial distribution 20, comma P. Number of trials, probability of success. Expectation of X is 20P. 20P is 1.4. P is 1.4 over 20. That is 14 over 20 into 10. So therefore, this comes out to be 7 over 100. So this is 7 to 7 to 10, 7 over 100, 0.07. That is the probability of success. Let's double check the value. There it is, 0.07. The next one. Calculate the probability. This is part 1. This is part 2. I need to copy this and paste it on the next page because I'll be needing more space. So now it says, second part, calculate the probability that a randomly chosen box contains at least one cracked egg. So you will write it again. That is X follows a binomial distribution 20, 0.07. At least one. Probability of at least one is 1 minus probability of 0. A very important rule will also be used in third part. This is 1 minus 20C0. Success 0.07 raised to power of 0. 0.93 raised to power of 20. Write it again. 1 minus 0.93 raised to power of 20. Then use a calculator and I'll just look at the value. This is coming out to be 1 minus 2342, 766. 1 minus 2342. 2 after rounding off, 0.766, correct to three significant figures. I think I left something out in the first part. Calculate the probability that the randomly chosen box contains exactly two cracked eggs. So X follows a binomial distribution 20, 0.07, exactly 2. Probability X is 2. That is 20C2. This is success raised to power of 2. This is failure raised to power of 18. Use the calculator and this answer is coming out to be 0.252. So this answer is 0.252. Always make a habit of writing the final accuracy level, which is 3SF, unless otherwise stated. All good, all clear. So now, people, let's look at the last part. Before that, we need the answer for the previous part. So let's read it first. That is this thing. A shop sells n of these boxes of X. Find the smallest value of n such that the probability of there being at least one cracked egg, at least one cracked egg. That means part 3 is related to part 2. In each box sold is lesser than 0.01. I think this is the trickiest question. The reason is the answer of part 2 is needed. So one answer is used for the other part. So answer of part 2, the unrounded value, let me write it, 1 minus 2342. This is 7658. This is 0.7658. That is the 4 or 4 SF value. We'll be using it for part 3. Now, this is the probability of success. And there being at least one cracked egg in each box. That means this is a combination of at least one and everything. So now over here, you will write this thing. Y follows a binomial distribution n comma answer of part 2, which is 7658.7658. This is at least one cracked egg. This is the answer of part 2. In each box, every one of them, probability y is equals to n. That is NCN. This is success raised to power of n. This is failure, whatever that is. So that is 1 minus 0.7658 raised to power of 0. Therefore, this is 0.7658 raised to power of n. Got the idea? So this was, the trick was, we are used to at least one. At least one cracked egg, that is this thing. The answer of part 2 becomes the probability of success of the last part in each box. This is happening in each box, all of the box. If there are n boxes, this is happening in all of them. So now you would say this thing is lesser than 0.01. 0.7658 less power n is lesser than 0.01. ln 0.7658 raised to power of n is lesser than 0.01. N ln 0.7658 is lesser than ln 0.01. N is greater than, because this will be something negative, lesser than something negative. So n is greater than these two values. Let me divide. So use bracket, that is ln 0.01, a bracket closed divided by another bracket, that is ln of 0.7658, and close the bracket. This is coming out to be 17.25. This is 17.25, and yes, it's a single flip. This becomes greater. So pick the next integer, and the next integer is what? N comes out to be 18, and that is the answer right over here. So yes, this was very tricky as compared to the previous questions that we have done in class. Because why was it tricky? The answer of part 2 became the probability of success of the last part, and the next reason is this thing in each box. This is happening in all of the boxes. If they're in boxes, it's happening in all of them. So that's what made it tricky. So that we are done with binomial probability distribution. So now the last part of this revision exercise, that is about permutation combination. And before we proceed, let me just pause the recording. So now people, let's get started with this thing, that is permutation combination, the last part of the journey, the revision journey. Now, what have they written in the syllabus? No harm in reading it. Now it says candidates should be able to understand the terms permutation, combination, solve simple problems involving selection. Well, they are not so simple. Solve problems about arrangement of object in a line, including those involving repetition, yani identical alphabets, restriction, that is the number of ways several people can stand in a line together, not together, separate, and also and so on. Questions may include cases such as people sitting in two or more rows. Questions about objects arranged in a circle will not be included, so that is not part of the syllabus. Let's read the first question. First of all, you read it, then I'll read it. The first thing is it has got identical objects. Both parts are about arrangement. So let me just highlight it. This is about arrangement. This is about arrangement. This is an NPR question. Second thing, what I need to do is this thing. Just highlight it. There is 1E, there is 2E, there is 3E, and then there are two L's, and then there is a J, an R, a W, and a Y. Altogether, this is 9. First thing, uh, in which they are asking this thing, that is in which the three E's are together and the two L's are together. So we are talking about two boxes. So let me draw the first box. The first box is of three E's. And then there is another box that is about two L's. And then there are others, just random numbers. So now, first of all, let me write this is E, E, and E, and then this is L and L, and this is J, W, R, Y. They are in boxes. This is 1, 2, 3, 4, 5, and 6. That is 6 factorial. What is happening inside the first box? Nothing. That's 3 factorial divided by 3 factorial. What is happening inside the L box? That is 2 factorial over 2 factorial. Now, some people, they ask this question, why two boxes? Why not one single box? The reason being, they are saying the two L's are together. They are saying three E's are together. So separate box for E's, separate box for L's. This is the first thing. So the answer is very simple, 6 factorial. That comes out to be 720. Exact. Leave answer in exact form. So permutation combination, there is no rounding off unless instructed by the examiner. So there is no rounding off. All done. Part B. Find the number of different arrangements that can be made from 9 letters of the word in which the two L's are not next to each other. So part B, let me do it in two ways. Method 1, method 2. The two L's are not together. So we are talking about two letters. This method is not together. It is applicable. And over here, also separated is applicable. So separated is applicable. And this thing is applicable not together. Why? Because these are two letters. So method 1, this is without any restriction. Without any restriction. How many are there? 9 factorial divided by 3 and 2 factorial. 9 factorial divided by 3 factorial, 2 factorial, 3 factorial for the e's, 2 factorial for the l's, whatever this answer is. And then the next one is together. So if we take the two L's together, it's about the L's, right? Two letters, L. So if I take the two L's, put them in a box, I'm left with three E's and J, W, R, Y. 1, 2, 3, 4, 5, 6, 7, and 8. That is 8 factorial. Into the blue one, that is 2 factorial. Inside, outside, divide by 2 factorial because both are L's, divide by 3 factorial because they all are E's. So this is without any restriction. This is together. Let me add a page. And then the difference. So difference between together and not together. So difference between without any restriction minus together will give us not together. Let me show you the working in a short while. So now, and I can show it right now. The first one, that is 302406720, 302406720, 30240 minus 6720. How much is the answer? The answer is 23520. This is 23520. Again, the answer is exact. Method 2, separated. So for separated, we want the two L's to be separated. So there are 1, 2, 3 E's. And let me push this thing to the left. And then there is this thing that is J, W. That's too much space. That is J, W, R, and Y. Let me fill up some spaces in the middle. So that is 1, 2, 3, 4, 5, 6, 7, and 8. So in these 8 spaces, 8p2 divided by 2 factorial for the L's. So the L's are over here, the 2 factorial. And what about these ones? That is 7 factorial for these letters divided by 3 factorial for the E's. So this is 3 factorial for the E's. So this answer will come out to be directly 23520. This is 23520. This is the space concept. This is the space concept. All good. So now this thing is done. Next one. Question, this one, in a music competition, there are 8 pianists. So there are this thing that is the 8 pianists, and then there are 4 guitarists, and then there are 6 violinists. So now this is like that something, music type of thing. And let's see what goes over here. So now it says 7 of these musicians will be selected. 7 you have to select. Go through the final. How many different selections of the 7 finalists can be made if there must be at least 2 pianists? So at least 2 pianists and at least 1 guitarist and more violinist than guitarist. So now this is like something you have to juggle. And the word over here is selection. That means this is about NCR. The word over here, where it is, was about arrangement. So therefore, this is NPR. So one question totally arrangement, one question totally combination. And yes, of course, there could be a mix and match of this. So now let me write this thing. That is, first of all, we have the pianist, and then we have guitarist and violinist. Let me write the whatever the order is. we would all get mixed up. So now, first the guitarist and then the violinist. Okay, so pianist, black marker, that is pianist, that is guitarist, that is violinist, that is 8, that is 4, that is 6. At least two pianists. That means let's start with two. Two pianists, it could go up. At least one guitarist, let's start with one, it could go up. And since I need a total of 7, so let me choose how many? 2 plus 1 is 3, so 4 violinist. That is the first option. Now, what I can do is that let me increase the number of guitarists. So now, this one guitarist, I'm increasing it to 2. And I can keep this pianist the same as before. So 2 plus 2 is 4. Therefore, the violinist is decreased by 1, but still violinists are greater than what? They are greater than the guitarist. That is the second option. The third option, let me increase the pianist. So now I'm increasing this pianist to 3. And if I want this thing to be more, violinist should be more. So I cannot have 3 and 2. So actually, this is 2, 1, 4, that is 7. Let me double check. 2, 2, 3, that is 7. If this is 3, what about this 2, 3? Is this a possibility? No, that would be 8. What about I use this original one, 1, and this is 3? Yes, there is a possibility. So now let me reduce this thing to 1. And now the guitarists are still 3, like this. And let me change the color. Why am I writing in purple when I can write them in green color? Okay, so now this is another combination. And last but not the least, let me increase this to 4 because it's at least 2 pianists, at least 2 pianists, at least one guitarist. So if I increase this to 4 and I want violinists to be more, so let me write 1 over here. 4 plus 1 is 5. And then this green one is 2. I think these are the different options. If you can think of any other, justify it. So now over here, let me write it. This is 8C2 into 4C1 into 6C4. This is 8C2 into 4C2 into 6C3. This is 8C2 into 4C, 8C3, 8C3 into 4C1 into 6C3. And the last 8C4 into 4C1 into 6C2. Let's look at the mark scheme. So one combination is 2, 1, and 4. So 2, 1, and 4. I think they have written violinist first and then the guitarist. Doesn't make a difference. 2, 1, and 4. That is this thing. That is 1680. So let me write each one down. This is 1680. The next one is 2, 2, 3. They must have written 2, 3, 2. Is there anything 2, 3, 2? Yes, that's the one, 3360. So this one is 3360. Choose something which is 3 and then 3 and then 1. 3, 3, 1, that is 4480. This is 4, 4, 8, 0. And the last but not the least, 4, 2, and 1. So 4, 2, and 1. Yes, there it is. 4, 2, 1, 4200. And 4200. And the total is the addition of all these. That is 13,720. So again, the answer is exact. But yes, it was a tough question of combination. So 2 questions are down. Third one. Now, this is a mix of permutation and combination. So this third one, it's a mix and match. This is permutation. This is combination. which one is permutation, which one is combination. So it's a good idea. First, read through every single detail. Find the number of different ways in which 10 letters of the word summertime can be arranged. So arranged means this is permutation. So that there is an E at the beginning and E at the end. That is the first one. Let me read the second one. Find the number of different ways in which 10 letters of the word summertime can be arranged. So now this is also arrangement so that the E's are not together. Third one. It says 4 letters are selected from the 10 letters of the word summertime. So selected, that is combination. Find the number of different selections if the 4 letters include at least one M, exactly one E. So this is like the identical thing selection that we have done thoroughly in class. So now, first thing first, let me write summertime. SUMMERTIME and E. This is summertime. So what do we have? We have this thing that is 3 M's are there, and then we have 2 E's are there, and then we have this thing, green color. This is SURTI. So altogether, this is 10. So now I'll just write it something on the next page. Let me just copy this. Let me paste it over here. Let me crop it. And I just need the last part. I'll do it over here. The first 2 parts over there. And let me also crop it over here. The first 2 parts over here. Okay, and let me just remove this green color from here. Okay, and then there are 3 M's and 3 M's, 2 E's. So let me write it also over here. The planning for this. E's and then 3 M's and then the other ones. So let me just manage the whole thing very efficiently. SURTI. This is this thing, and then we have 3 M's and 2 E's. So there are 3 M's and then there are 2 E's, and I can do it in any order. Now it says find the number of different things in which E at the beginning, E at the end. So part 1, E at the beginning, E at the end. So doesn't make a difference. Remember that example, Xerox copy, photocopy of the same thing. So these two are used up. We are left with 8. So write 8 factorial divided by 3 factorial for the M's. So we are dividing by 3 factorial for the M's. That is how this thing is done. That is the answer for the first part, 2 marks. Second part. Now it says find the number of different arrangements, different ways in which 10 letters can be arranged so that the E's are not together. So the E's are not together. Let me do it the separate way. E's are not together. In the previous example, I have taught you 2 ways. The first question, now just 1 way. So let me write S. Let me just push this thing to the side. Okay. So now we have SURTIMM and M. So we have 1, 2, 3 M's. So this is 1, 2, 3, and then we have these ones 1, 2, 3, 4, 5, 8 of them. And yes, there are some gaps in the middle. So 1, 2, 3, 4, 5, 6, 7, 8, and 9. We have to fit in the 2E's. So this is 9P2 divided by 2 factorial. This is for the 2E's. And that's over here, the E's and the E's. And what about the rest? This can be arranged in 8 factorial ways divided by 3 factorial ways for the 3 M's. Double check the answer. First one is 8 factorial over 3 factorial. 8 factorial over 3 factorial, 6720. So this answer is 6720. That is 6720. And this answer 9p2, 2 factorial. 8 factorial, 3 factorial. 9p2, this is 9p2. 2 factorial, 8 factorial, 3 factorial. This answer 241920. No matter how big the answer is, leave it as it is. 241920. If I'm not mistaken, 241920. Good. Now let's focus on this. 4 letters are selected from 10 letters of the word summertime. Find the number of different selections if the 4 letters include at least one M and exactly one E. So I need 4, exactly one E. Let me write down different options. I don't know how many they are. And at least one M. So it could be 1M, it could be 2M, it could be 3M, it could be 4M. And how many I need? 4. The first one is applicable, and I'll write 2 over here because I need a total of 4. 1 and 2 is 3, so I'll write 1 over here. 1 and 3 is 4, I'll write 0 over here. 1 and 4 is 5. This option is not applicable. So basically, discard the rest when we are dealing with identical objects. So I'll write 5C2, that is 10. I'll write 5C1, that is 5. I'll write 5C0, that is 1. Therefore, the total is 16. Let's double check, double check. That is it. All good, all clear? Okay. And let's do this one, the last question. Just read through it. I want you to read it, so I can just repeat part C. Part C, 4 letters are selected from 10 letters of the word summertime. Find the number of different selections if the 4 includes at least one M. So there are 3 M's. It could be 1M, 2M, 3M. Well, this one was anyway, the 4 was not applicable at all. So let me just remove this thing. Now, exactly 1E. 1E, 1M, 1E, 2M, 1E, 3M. You need a total of 4. When you have selected 2, you discard whatever is left. No one cares. You don't write 3C1 or 2C1, nothing like that. It's just like photocopy of the same paper. This is photocopy thing. You select 2 from 5, 5C2. You select 1 from 5, 5C1. You select 0 from 5, 5C0. That's it. And if you want more information, then watch the video once again. Now, last question. It says, find the number of different possible arrangements of 9 letters of the word celestial. C, E, L, E, S, T, I, A, and L. So now what do we have? We have 2 E's, we have 2 L's, we have 1, 2, 3, 4, 5 other words. Okay, so now it says the first one, very simple. Part 1, 9 factorial divided by 2 factorial and 2 factorial. The 2 factorial are for the, this one is the red one is for the E and the blue one is for the L. Part B, find the number of different possible arrangements of, find the number of different arrangements. So first of all, let me just highlight one other thing. That is arrangement, arrangement, arrangement with probability, and then 5 letters are selected, selection. So again, it's a combination of NCR and NPR. Okay, so first part is done. That is part A. This is not part 1. This is part A. Label it properly. Do not slack. Now it says find the number of different arrangements of 9 letters of the word in which the first is C, fifth is T, last is E. Wow. So now, first is what? First is C, CTE. C, 1, 2, 3, and then a T, that's the fifth one, sixth, seventh, eighth, and ninth. Altogether, there are 9. Okay. So now these are all fixed. So this is fixed, fixed, fixed. Out of 9, 3 are used up. How many are left? 6. 1, 2, 3, 4, 5, 6. So I'll simply write 6 factorial divided by 2 factorial for the L's. That is 720 over 2. That is 360. Let's double check the first two answers. That is 9720. This is 9720. And this is 360. This is 360. All good? Now let's move on. Let me copy this. And yes, I can copy this and paste it on the next page. Okay. Now it says, find the probability that the randomly chosen arrangement of the 9 letters of the word celestial do not have the two E's together. So this is just an extra thing of probability. So now, first of all, part C, answer of part A, that will be the denominator of the required probability. That is 9720. Leave it on the sidelines. Do not have the two E's together, so separate it. Celestial, what do we have? We have CSTIALL. C S T I A L L, and then 1, 2, 3, 4, 5, 6, 7, 8, 8p2 divided by 2 factorial for the E's, and multiply. What else? 1, 2, 3, 4, 5, 6, 7. That is 7 factorial divided by 2 factorial for the L's. So now let me just check this answer. That is 70560. So this is 70560. This is the numerator of the probability. So 70560 divided by 90720, 90720. This answer comes out to be 7 over 9. Leave the answer in the fractional form. So because fractions are supreme, fractions are beautiful, fractions are above all, that is exact. So that is why we are leaving this answer in this form. Now let's move to the last part. Copy and paste. And over here, I can crop. Okay. So now over here, what do we have? We have CSTIA. Let me write it first. And CSTIA. And we have 2 E's and 2 L's. We have 2 E's and 2 L's. And that is red and blue and green. So this is red. This not red. This is red. This is blue. And let me choose this thing on the side over here. That is green. So that is 1, 2, 3, 4, 5. And now I'm interested in how many alphabets? 5 letters selected at random. Find the number of different selections. If the 5 letters include at least one E, at most one L. So now write out all the options. At least one E. There are 2 E's. So it could be 1 E, and it could be 1 E. It could be 2 E. It could be 2 E. When we are talking about at most one L, so it could be 1 L, it could be 1 L, and it could be 0. So this is 1, this is 0. It could be 1, it could be 0. Now double check first. This is what you need to double check. Exactly 1E, exactly 1L. Exactly 1E, exactly 0. So this is taking care of at most. This is taking care of exact. At least could move to 2, again 1, 0. You need 5. So now you would write 1 plus 1 is 2, you need 3 more. 1 plus 0 is 1, you need 4 more. 2 plus 1 is 3, you need 2 more. 2 plus 0 is 2, you need 3 more. Now write down all the options. Again, the photocopy paper example. This is 5C3, which is 10. This is 5C4, which is 5. This is 5C2, which is 10. This is 5C3, which is 10. So 10 and 10 and 10, that is 30 plus 5. The total is 35. And the probability thing we already checked. Last one, 10, 10, 5, 10, 35, all good, all clear. So I hope I have wonderfully prepared you for the midterm exam for S1. Stay tuned for the P1 session. Take care, everyone.